Hello, I'm Professor John Kelly, and this is the Weber Auto YouTube channel. Today we are looking at differentials. I have 11 different types of differentials here on the table, and we are going to take a look at each of these, some of them in more detail than others. There's a lot of similarities with some, and some pretty good differences with others. So the first differential that I have right here is called an open differential. And an open differential is one that if traction is lost to one of the two wheels, the drive wheels, then that wheel is the one that receives all the power. The wheel that has traction gets no power, and the other wheel just sits there and spins. So let's take a look at an open differential, and then we'll compare that to various limited slip and locking and other types of differentials that give power to both tires at the same time on the same axle as this differential. So if we look at the individual pieces of the differential, this big piece right here that rotates is called the differential case, and it has a bearing on each side of it called differential side bearings. And inside of this differential case we have two side gears and two differential pinion gears. Sometimes people will refer to these differential pinion gears as spider gears because, I don't know, we already have a pinion gear with a ring and pinion gear set. The ring gear, by the way, or crown gear for as it's called in some European countries, would bolt to this differential case and rotate the differential gear set. So this is the second gear set inside of a rear axle or a front axle. So let's take the gears out and take a look at what's going on here. So on this particular model, there's a little bolt that we have to undo to remove this differential pinion pin right here. So we take this bolt out, it sticks down and engages with the pin to keep it from coming out. But as you can see, when I push it out, it has a hole in it right there where that bolt sits, and that's how it's held in place. But we're just going to pull that all the way out. Now, when we get that pulled out all the way, we have to rotate the side gears just a little bit here. And then one on each side, we can take out the differential pinion gear on the one side and the pinion gear on the other side. And then our side gears can drop down. Here's the side gear, and lift up over here is another side gear. All right, this particular open differential is out of a Ford Crown Victoria, one of my students' vehicles, where they replaced this open differential with a limited slip differential. Okay, so let's take a look at the differential side gears and the differential pinion gears. Now the side gears, let's start with those first. I have brought in an axle shaft right here, and you can see the wheel studs here on this side that your wheel and tire assembly would bolt to. And if I just set this in this little V block here, I want you to see that the differential side gear splines right onto that axle shaft, which means whenever you are driving down the road, it's the side gear that turns the axle shaft. It's the side gear. It's not the ring gear. It's not the great big ring gear like this one right here. It's not this great big ring gear. All that ring gear does is turn the differential case. The differential case turns this differential pinion pin right here, and that differential pinion pin turns the differential pinion gears. And it doesn't rotate the gears, it makes them makes this shaft rotate as an assembly as this differential case rotates. So as I have it oriented right here, it's just going to turn with the differential case. And as it turns with the differential case, it turns the side gears that go with it. Each side gear is connected to an axle shaft. Now this particular axle shaft is called a C-clip retained axle shaft, and we have this little clip right here, shim looking piece in the shape of the letter C, and there's a groove in the end of the axle shaft. So we have to push the axle shaft up through the side gear here and then push the C-clip in place and then pull the axle shaft back through the side gear, and the side gear then retains the axle shaft and keeps it from coming out of the axle housing as you drive down the road. All right, so to remove axle shafts, you have to remove the differential pinion pin to allow them to have enough clearance to push in and get the C-clips out. And then you can pull the axle shaft out of the side gear. The side gears sometimes will have a little shim behind them. On some axles, this is a selectable thickness shim. And so you put a shim in behind the side gear. There's supposed to be another shim right here. I've lost that apparently, and it goes up inside right here. The purpose of those shims is to control the amount of backlash, this play back and forth between the gear teeth right there. So if we put these differential pinion gears back in, and it can be a little tricky, you've got to visually line them up, make sure they're straight across from each other. They also have a little washer on the back of them to allow them to spin and stay lubricated and reduce friction. And then we'll put our differential pinion pin back in. We have to make sure that the side with the hole is on the side with the hole in the differential case. And then our locking pin goes back in right there. So, as I just explained, the axle shafts slide into those side gears. And the side gears, notice they can rotate in the housing, but when you put the two axle shafts in and put the weight of the vehicle on the ground, you'll notice one of these spins forward while the other one spins backward. So the vehicle is not going to roll forward or backwards because these gears want to rotate in opposite directions, so instead they just lock up. All right, so let's build just a little mock-up of the differential in the vehicle itself. I've got some V-blocks here. I'm just going to hook up a couple of axle shafts. Another axle shaft. And then those axle shafts, as I mentioned, slide right into the side gears. So I'll put one in the back here first. Okay, so I've got the axle shafts put into the side gears. Okay, notice as I turn the differential case, the side gears and the differential pinion gears are not rotating. And that's because we are driving down the road. We have equal traction and equal load on each axle shaft. But notice if one tire breaks loose and the other tire does not, I'm going to hold this axle shaft here from rotating. Now, the axle shaft over here is turning faster, and it's the only one turning. As a matter of fact, it turns 2 times faster than it normally would if both axle shafts were rotating together. And that's because there's a formula. The theory of how this works is 1 rotation of the differential case is equal to 1 rotation of one axle shaft plus 1 rotation of the other axle shaft divided by 2. So 1 is equal to 1 plus 1, which is 2, divided by 2, which is 1, which means 1 is equal to 1. I know that's a little confusing, but let's do the math now with one axle shaft stopped. If you watch this yellow mark right here versus this sticker right here, I'm going to rotate that housing, the differential case, 1 time. We've already had 1 revolution out of that axle shaft, and here comes the second mark right there again, but we only got 1 rotation of the differential case. So what that means is for 1 rotation of the differential case, we had 0 rotations of the left-hand axle shaft. We had 2 rotations of the right-hand axle shaft. 0 plus 2 divided by 2 is 1, which equals the 1 rotation of the differential case. Now, why would that? I mean, who cares? That's an engineering analysis that you would look at, or design feature. It'll give you an indication of the rotational speed of each wheel. So let's say that this axle shaft, instead of being stopped solid, is rotating half of a turn. So if it rotates half a turn, that means this other side will be rotating 1.5 turns. So no matter what, the number of rotations of this axle shaft plus this axle shaft always has to equal 2. So if we have 0.5 here, we have 1.5 here to equal our 2. So you can come up with any combination that you want there, but that's how it works. So this type of differential is really good at allowing for differences in tire speeds that occur as you turn corners. As you turn corners, the tires on the outside of the arc of the vehicle as you're rotating have to travel farther and faster. And so the differential allows that to happen. It allows for a difference in the rotational speed of those tires. Well, this is the style of differential that's been around since the beginning of the automobile, when they started using differentials, but they've been around longer than that. But the big problem is when you have one tire on a loose traction surface and another one not on loose traction. An open differential sends power to the one that has lost power. So for example, let's say this axle shaft is connected to a tire that has good traction, so it doesn't want to just spin, but the other one is on ice. As I turn the differential case with the ring gear, notice no power at all goes over to the tire that has traction. It sends all the power to the wheel that has lost traction. And so for years and years and years, automobiles had this problem before paved roads were common everywhere. Dirt roads, muddy roads, snow, gravel, whatever it may be, cars would get stuck. And you would only have one rear tire on a rear-wheel drive vehicle that would have any power to it, and that caused problems. So over the years, the engineers tried to come up with different ways to send power to both wheels. And it wasn't until Dana Corporation, which should sound familiar to you, if you've watched any of my universal joint videos, you know there's one on the history of universal joints where Clarence Spicer of the Spicer U-Joints, Spicer Driveline division of Dana Corporation, started the company, and then this Charles Dana took over and as a business manager and ran the company and ran it for many, many years, and they named the company after him a little bit later. But Dana Corporation out of Toledo, Ohio, in 1956 released a limited slip, or they call it a locking differential, for use in automobiles. And so the very first vehicle to use it was a 1956 Packard, and they called it a twin traction differential. It cost an additional $35 to $50 depending on the vehicle. And then in 1958, that same differential was used by almost everybody else. So Chevrolet picked it up and calls it Posi Traction. Pontiac picked it up and called it Safe Track. Studebaker and Packard called it Twin Traction. Chrysler called it Sure Grip. American Motors called it the Power Lock. And Oldsmobile called it the Anti-Slip. Ford offered it in some Lincolns. I don't know what they called it in the Fords. But this is out of a New York Times article from 1958 talking about this amazing invention of the locking differential. So the rest of these differentials that I have here are not open differentials. They are different methods of trying to send power to both wheels under varying conditions using different mechanisms. So let's take a look at the version that Dana came up with, and this may not be the exact 1956 version, but it's pretty close to it. So let's take a look at that next. Okay, our next differential right here is from a 1965 Chevrolet. So this would be what Chevrolet called Posi Traction. And this was only, let's see, 1958. So that's 8 years after the invention from Dana Corporation of the locking differential, as they called it. Now, the name locking differential is misleading. It doesn't lock the two tires together. It comes close to locking them together, but it does not. It allows for a limited amount of slip, hence the term later on of limited slip differentials. So let's take a look inside of this differential case. This differential case splits in half. On any differential case that splits in half, you better make an alignment mark because it has to go back exactly where it was. And so I'm just going to take the bolts out. They're loose. And we'll lift the upper cover off. Looks like this. And then I want you to see that we have a steel plate with tabs on the outside of it, these little tabs right here. And then we have a steel plate with teeth on the inside of it. And then another one with tabs on the outside, and another one with teeth on the inside. And these fit all together in what's called a clutch pack. Clutch pack. And that slides onto this little piece that the side gear fits into. So the side gear is right here, riding inside of this little cup, and then we've got this clutch pack on the outside of it here. On the clutch pack, these little tabs, these grooves, fit down into these notches in the differential case, which means that as the differential case rotates, these plates with the notches also rotate. But the gear, the little cup with the gear in, it doesn't rotate with those notches. It rotates with the little clutch plates that had the teeth on the inside. And the way clutch packs work is if we can squish these together, then they will turn as one assembly. But if we're not squishing them together, then they can rotate relative to each other. Okay, so we've got a differential side gear with a clutch pack. Then we have 4 differential pinion gears. This one is missing one. I only have 3. Can't find the 4th one. But the more differential pinion gears you have, the stronger this differential is. Because if we go back here to the open differential just for a moment, these 2 side gears have to transfer all of the power, all of the torque from your high performance engine and haul that big heavy vehicle down the road one tooth at a time. So if we just had one differential pinion gear, there'd only be one tooth transferring that power. By having 2 pinion gears, there's 2 teeth transferring the power. By having 4 pinion gears, there's 4 teeth transferring the power, and so on. The more you have, the more power it can handle. And then in the other side of our differential case here, let me just turn it over and dump it out. There we go. We have the opposite side clutch pack and side gear, just like we had on the other side. Now, one other thing I want you to see is that in the center of this side gear, it has splined teeth, and in the center of this little cup that holds the side gear, it also has splined teeth. So when you put those 2 together, you have to line those splines up in order to put the axle shaft in. This old style didn't use C-clips. It had bearing retainers on the outside of the axle instead. But you've got to line those up before you put it back together, or you'll never get your axle shafts back in, as I found out the hard way years ago. So what are these clutch packs for? What do they do? Well, let's take a look at just one side gear and one differential pinion. Notice they have beveled teeth. There's quite a slant to the gear tooth. And as these teeth rotate relative to each other, they want to push apart from each other. They push themselves apart. So let's build the clutch pack with all the gears without the differential case being involved. So we'll put the differential pinion gears in, just like that. And then the other side gear, just like that. And then the other cup and clutch pack. So now, as you're driving down the road and both the left and right axle shafts have equal traction, this entire assembly rotates as one piece. There's no rotating of the gears relative to each other. But if one tire lost traction, notice that would cause the differential pinion gears to rotate. And as those gears rotate, they push apart from each other. So if we pick this up and look at it from a side view here, as this rotates, it pushes apart. It pushes apart. It squishes these clutch packs together. As they squish together, they try to lock the differential case with these tabs here to the side gear, which is the clutch plates that have the teeth on the inside of it. So that tries to connect all of them together as one big assembly, and it sends power to both axles rather than just one. And so one more time, these clutch packs, this was the invention. These clutch packs aren't used unless there is a difference in rotational speed between the left and right axle shafts. And then they get applied by the gear teeth profile, causing the gears to push apart, and they force those clutch packs to apply. Now, that's only going to work if the backlash, the amount of play in between the gear teeth, is set properly. So sometimes there's an additional shim in here, a backlash shim, that is a selectable thickness shim that you will go in and put in place. You'll assemble the differential case, and then you'll measure the backlash with a dial indicator. And if the backlash is too excessive, then as the gears push apart and try to apply the clutch packs, they won't have enough distance to push, and the clutch packs will slip, and it won't send power equally to both left and right axle shafts. If the backlash is too tight, then it might be always applied to where you turn a corner and it's dragging the tire around. The outside tire, as you turn, is turning the same speed as the inside tire, so it's skidding and dragging and turning at the same time as the inside one. So that can cause these clutches to slip and grip, cause a chattering sound as you turn corners. And so differentials that utilize clutch packs like this require a special lubricant, and there's a limited slip additive, or LSD additive, as you'll see on some gear oil containers. If you have a limited slip or clutch style differential, then chances are pretty high that you need a limited slip additive to keep them from chattering when you're turning corners. Okay, so this was the invention, to get these clutch packs that will apply automatically when there's a difference in rotational speed of the two tires that hook to that axle. But what's neat is that once both axle shafts are turning the same speed, the clutch plates release. And then if the backlash is set right, as you turn corners, there's no chattering. It just acts like an open differential as you turn corners at low speeds, but then it tries to lock the two axle shafts together, but it never totally locks them together. There's actually a test where you can take a torque wrench and a special adapter and put it out on the axle shaft and push down and measure how much torque it takes to break away the clutches, to not break the clutches, but make them slip. And most of them are around 250 pound-feet of torque, 300 pound-feet of torque for the breakaway. So there's a test for these, and they do wear out. All right, so this is the original style limited slip differential. Let's get it out of the way now. This is a little bit newer version of the same thing. It has a one piece instead of a split differential case. And I'm not going to take it apart. I want you to see that right here are the clutch plates. So at first glance, this may look like an open differential. But if you see those clutch plates, then you know that it is some sort of a limited slip, or all those other words that I read off of that New York Times article. One of the most popular ones was Posi Traction. When I was a kid, we didn't know that Chevrolet was the only one that used the term Posi Traction. We just used the term Posi. Does your car have a Posi? And it's not very cool unless your car has a Posi. So that Posi for Posi Traction. All right, so here's just another example with clutch plates. Here's one out of a 1984 Corvette. And if you look right down here under the side gear, you can see the clutch plates of the Posi Traction in the 1984 Corvette. Then This one I purchased from Eaton Corporation. I bought it about 10 years ago. It's a brand new, never been used. This one they actually call the Detroit Locker, or Posi, as I've mentioned. And it not only has the clutch plates that you can see sticking through the top here. You can see the clutch plates through the holes here. But this one has what's called preload springs right here. Preload springs. And so what that means is that these springs right here are pushing the side gears apart as far as they can, but without totally applying the clutch plates. They're just slightly applied. And that forces the backlash to its maximum in between these gear teeth here, which gives a quicker reaction time when there's any type of a slip. We don't have to push out on the side gears to apply the clutch packs. They're already pushed out and taking up all the play that was in the clutches. Now we just push out and apply with a variable load, depending on the difference in speed there, the clutch plates. Now this is the type of axle that we had in our cars as kids back in the 70s. And to get that out, to get those springs out of there, and they're pushing, the springs are pushing on two plates that push against the side gears. That's hard to get out. You're getting in there with pliers trying to squish it down, and later on when zip ties became strong enough, you could squish it down, get a strong zip tie in there, and it would hold it compressed. But there was actually a special tool, I've got one right here, that reaches in and grabs the spring, and then you tighten this down and it'll compress the spring down and you can take the spring out. But this one must have been for a little smaller diameter springs on an older axle than on this newer one here. But this one can still reach in and grab the top and bottom. Let me turn this around so you can see it. The top and bottom of that plate, and then squish it down enough to get some zip ties in there and pull it out. So we've got two springs on the front and two more springs on the back. These are very difficult to get apart, very difficult to put back together. And if you don't get your backlash set just right, you got to do it all again. But this is one that you can still buy today as a replacement for an open differential or another type of differential that we'll take a look at later that comes in a lot of General Motors trucks, called the Eaton Locker, which is also a misleading term. It doesn't lock the tires, left and right tires together. It does something else, but we'll take a look at that a little bit later. So we've taken a look now at three different clutch style, limited slip, Posi Traction, whatever term you want to use. They're all working the same. Differentials. And the fourth one, the old original one from 1965, Chevrolet, all of these were based on that original Dana 1956 release of their invention to the automotive industry. Now I've got another one right here I want to show you, because this one is worn out. I want to show you clutch plates that are worn out. So this came out of a 2010 Chevrolet Camaro Super Sport. This was one of my students' Camaros, and apparently it started having a one tire burnout instead of two. And so the student decided he wanted to change gear ratios anyway and put in a different style of differential that didn't wear clutch plates out like this. Some people call it a torsion limited slip differential, but it uses gears instead of clutch plates to do the same thing. I've got one that's similar to that over here, a Detroit True Track. But let's take this one apart. This one also has a split differential case. Okay, in case you're wondering, yes, I did make an alignment mark right here on the two case halves. You should also make an alignment mark if you're going to remove the ring gear from the differential case, but we are not. So let me lift up the differential case. Notice the inside of it looks very familiar. Looks a lot like that original or that old 1965 version. Okay, we have a side gear, two differential pinions, and another side gear. And behind each side gear is a set of clutch plates. So we have the shim that controls backlash. Notice this does not have teeth on the outside or the inside. Then we have a clutch disc right here with teeth on the inside. Notice it's metal on one side and has clutch fiber material on the other, but it's almost totally worn off. And then here's a steel plate that has these little notches on the outside that spline into the case, differential case. And then here is a double-sided clutch disc that almost all the clutch material is worn off of this side and a lot of it worn off of the other side. And then another steel plate, and then a dished, like a cereal bowl, spring that puts a little preload. It's kind of like those big heavy springs in that last axle that we just looked at. So this is really worn, and that's because this car was driven quite aggressively. So as there was a little bit of slip from left to right, depending on the traction of each tire, these clutch plates with the splines on the back of the side gear, whoops, got upside down here. The steel plates with the notches rotates with the differential case, but then the steel plates with the clutch fiber material on rotate with the axle shaft. And so as the gears teeth push themselves apart and tried to apply this, eventually all that material wore off and it no longer functioned properly as a limited slip differential. Okay, so that's a newer version of the exact same thing. Let's get that out of the way for a moment and let's move on to our next style of differential. This one also came from one of our students. He had and still has, I think, a 2005 Jeep Wrangler Unlimited Rubicon with a rear air locking differential. And he was out four-wheeling and broke his differential. And it broke because of the off-roading he was doing. Big tall tires put a lot of extra strain on the axle shafts and the side gears down inside of the differential case. So this is an air locking differential. So let's take it apart and see what's unique about the air locking portion here. Okay, I've got the bolts out of it. Notice I've got an alignment mark right here for the upper and lower halves. And I'm going to lift up the upper half. Here we go. Now this has a kind of a dog tooth mechanism to connect the equivalent of a side gear, but notice this has broken teeth on it from the extreme off-roading that this student did. And instead of a clutch pack behind the equivalent of the side gear here, it has this toothed wheel and another toothed wheel. This upper one has these 4 tabs that stick up through and rotate with the differential case. So it rotates all the time with the differential case. This one only rotates with the axle shaft. And then there's a spring that goes in between them. So if we lose traction, then we use compressed air to push this set of teeth into this set of teeth. Just like that, locks it together. And then there's a spring that pushes it apart when we don't need it applied. And that spring is right here. So let's set the apply plate right here that gets squished with compressed air. There's a little plate right here that sits on these 4 tabs on the outside of the differential. And then there's this piston assembly here that if I were to get some compressed air, don't put it on that fitting right here or it'll pop the piston right out. But keep the compressed air back several inches and just blow it on there. This will push outward and it sits right here. So when compressed air is applied to that piston, it pushes down and locks the gears together. So that's the air locker. But the original differential that came in the Jeep Rubicon only had that on one side. You can buy extra heavy duty ones, which this student did, and put in his Jeep that has lockers or locking teeth on both side gears rather than just one side gear. But if you lock up one, it still works. But if you lock up 2, then the second axle shaft is also locked directly to the case without the torque having to go through the differential pinion gears. Now, another unique thing besides this being a locking differential is that this is also a torsion differential. So if I turn this over, this gear right here that I said was the equivalent of the side gear looks nothing like a side gear. It's the gear teeth are straight up. There's no angle to it at all, and it meshes with some other gears that are in here. So this is called the torsion style differential. The torsion company doesn't even exist anymore. It's been sold and bought by different companies, but everybody keeps calling it torsion. But there's another side gear, of course, one for each axle shaft. So we'll pull the cover off the other side. And we've got 4 more gears right there. Right there. Okay, I've got this torsion differential disassembled. Notice it has some strange holes in it. This differential case, and that is for all of these gears right here. We've got some short gears and then we have some long gears, and then we have our 2 side gears that the axle shafts, you can see the splines inside of them that the axle shafts sit in. And then to keep these side gears from slipping relative to each other when you lose traction, we use these long gears and short gears. And so let me turn this over. We are going to have take 4 long gears and they will contact the side gear on the top in my example here, and they're evenly spaced. And then we have the shorter gears here, and they come in and contact the long gear on the bottom, but also the opposite side gear on the bottom. And then as one gear tries to rotate relative to the other one, these gears, the short gears versus the long gears, tend to want to push themselves apart and away from each other. So both side to side and up and down, they tend to want to push. And that makes them wedge in place inside of the bores that they sit in, which slows them down and makes the entire assembly turn as one piece. So it mimics what the limited slip clutch plates do, except it does it with gears. And it's quite a ingenious invention. It's been around, like I say, for quite a while, and it shows up now and again in different vehicles. It's pretty common in high performance vehicles today because the clutch pack style design doesn't seem to be strong enough for the super high torque and horsepower of the vehicles of some of the vehicles of today. Okay, so this is a torsion style limited slip differential. Since it does not use clutch plates, it does not need limited slip additive. It just uses regular gear oil or whatever well, not regular gear oil. Nothing uses regular gear oil. Look in your owner's manual to determine the correct type of gear oil that goes in your differentials and transfer cases and so on, because it impacts a lot of things, including your fuel economy. All right, so that is quite an amazing differential assembly. Not only do we have a very high-tech torsion limited slip, but it's also an air locking differential. So that's pretty cool. And that's in the Jeep Wrangler Rubicon. And that's from one of my students. I have 3 students. The open differential, thank you, Jake. The worn out Camaro differential, thank you, Cade. And the Jeep Rubicon differential, thank you, Jacob. They work great for these demonstrations. All right, the next differential I want to show you is a Toyota version of a locking differential. This differential has 4 pinions, 4 differential pinions, so that's pretty strong. It does not use clutch plates, so it acts as an open differential normally, but if you want it to lock up solid, and by the way, when we have an air locker, like that Jeep Rubicon differential we just looked at, it truly is a locker. It locks the left and right axle shafts together. There is 0 room for slip. And if you try to force it to slip, bad things can happen, like broken gear teeth. Or give it too much power or whatever it may be. So this acts as an open differential. We can look right here on the side, and this is one side gear. It has a bunch of splined teeth, and then we have this sleeve right here. Has teeth on the inside, it has teeth on the outside, and this sleeve can go all the way down in, and that forces the left and right side gears to rotate with the differential case. But if we pull it out just far enough, then it becomes an open differential again. So this is an open differential or a locking differential. There's a clutch fork, as you can see in this photo right here, that slides into this groove and has an electric motor that moves it out or back in. So instead of it being an air locker like the Jeep Rubicon one that we looked at, this is an electric locking one. Now there's also an electromagnetic locking one that moves similar devices that cause either an open differential to turn into a limited slip, or to take a limited slip and make it a locker, or make it open differential into a locker. There's all kinds of combinations. But this is what Toyota did on the Tacoma and other vehicles, that to just make a quick transfer into a locking differential. Typically, I believe this was only available in four-wheel drive low. Correct me if I'm wrong. And it had a front locking differential, a rear locking differential, and a transfer case that would lock as well. So under certain conditions, for maximum traction, you get all four wheels turning the same speed with no slip at all on any of them. So that's another locker. This differential is called the Detroit TrueTrack, and it is nothing more than Eaton's version of the Torsen differential. So let's just hurry and take the cover. We'll just take off one cover and look at one side. Both sides are the same. So you can see down inside here, a little closer view. Here's our side gear right there. And then so there's 3 sets of gears on each side gear. There's not long and short ones, so that's different than the Torsen. But they do intertwine, or intermesh. The ones in the bottom mesh with the ones on the top. They push themselves apart and up and down to wedge themselves in place to stop the left and right axle shafts from spinning at different speeds. So this is just another version, works very well, of the Torsen limited slip differential, except it is actually different, although it looks a lot alike. But it's called the Eaton TrueTrack. This differential, when I bought it 8 years ago, was probably $800, which is a pretty typical price for a brand new differential back then. I haven't priced one of these this year to see what it is, but anyway, that's another option that you have. Speaking of locking differentials, you can purchase for off-road or racing purposes something called a spool. And a spool would look like a differential case like this, except without any rotating differential gears. It would just have the splines for the axle shafts on each end. Now, if you look at this photograph right here, we use a spool in the front power transfer unit, the PTU, in an all-wheel drive crossover SUV. There's no differential gear set at all. It's just one turn of the ring gear of the differential case gives us one turn of each axle shaft. But that's a different story. But you can also buy something called a Mini-Spool. And a Mini-Spool, let me just show you this. Let me see if it'll actually fit in this Ford differential. With a Mini-Spool, you take out your existing differential pinion gears and side gears, and then this piece right here replaces the side gear. So it has the same splines but no teeth, and so it comes and fits inside in place of the side gear, just like that. And then there's another one that you would put in the opposite side. This one is for a Chevrolet, and I've got a Ford axle here, but it would go in on the other side. And let me show you how it works on the outside here. Once you get the 2 side gears in place, then you would slide the equivalent of your differential pinion gears in, just like that. And then you take your pinion pin and put it through and lock it in place. And once that's done, this entire unit spins with the differential case. There's 0 gears to allow any rotation, and you've just turned your limited slip differential into a spool. And it's quick, fairly quick and easy to do. Of course, you have to take your axle shafts out to do that. So it'd probably take you a half hour to swap this out and put it back together. But that's a quick, easy way, and that's a lot better way than welding these gears together. Because once you weld these, you're done. There's no undoing it. Plus, welding cast iron like this takes a specially trained welder, special procedures, and it's just a bad thing to do, welding a differential. I know it's a cheap, easy way to get yourself a spool, but then you've got 0 slip. And if you're driving that on a public street, you're going to be wearing your tires out super fast, and you're going to hate it for the most part. All right, so that is a mini spool. You can also buy just a full-size spool. All right, now our very last differential to look at is used in, or has been used, and still is, in General Motors products since, I believe, 1967. If you get a General Motors, a GMC or a Chevrolet truck that are rear-wheel drive, you will get, if you order the upscale package, you will get an Eaton Locker, or you will get an open differential. That's all there is to it. So if you order the limited slip differential, you receive this differential right here called the Eaton Locker. Now, I'm not going to take this Eaton Locker apart. It would take as long as this video is already to take it apart and put it back together, but it is serviceable. It must be set up properly. But let me just explain the basics of the Eaton Locker. If the Eaton Locker is set up properly, this acts just like an open differential the majority of the time you're driving. So that means it does not need limited slip additive. This just drives around like an open differential. There's no chattering when you turn corners. But once there is a 100 RPM speed difference between the left and right rear wheels, then this little shaft right here called the governor has these little spring-loaded flyweights that fling out, and as it rotates they fling out, and it can grab this piece right here and lock the two together. And then there's something inside called a ball ramp that will rotate and apply the limited slip clutch pack. It has clutch plates on the left and right side gears. So think of it as one of the old school differentials, limited slip differentials, except it has this switch called a governor that can switch it between an open differential and a limited slip differential. So it's the best of both worlds. It really is a nice differential. It's not super heavy duty, so if you're into rock climbing and off-road, four-wheel drive, whatever, this probably isn't going to last a super long time for you, but it'll work. As long as you don't give it shock loads, it'll work just fine. But so one more time, this is an open differential that suddenly can be switched to a clutch plate style limited slip differential, which is pretty cool. There's a special tool right here to come in and remove some press pins and get these governor and flyweights out of here. And then there's a spring, or there's a big block in there in between the two side gears to transfer the clutch apply pressure to each side gear, because the apply pressure only comes from one of the side gears. So it has to transfer through into the other side gear through this block. This block comes in different thicknesses. When you put this together, you got to set your backlash properly. There's a different backlash for the left side gear versus the right side gear. And once your backlash is set right, you take a tool and measure the distance between the two side gears and subtract a certain amount, and that's the thickness of the block that you put back in there. So hopefully someday I'll do a video on the complete disassembly and reassembly of this. I'm just out of time this week to do that for my students, but it can be done. You don't have to replace the entire thing, although trying to find parts might be a problem. I had a student here years ago that tried to rebuild one of these, and it took quite a while for the Chevrolet dealer to be able to get the repair parts that he needed. Okay, so to wrap up here, we learned that the first limited slip or Posi differential was developed by Dana Corporation and released in the first vehicle ever in 1956 and has been used ever since. There are clutch plate style limited slip differentials. There are the gear style. We've got the torsion style limited slip. We've got the Detroit True Track style limited slip. We've got locking differentials that are electrically locked. We've got air locks. We've got, on older vehicles, there was a mechanical lock that could occur to engage those. They all have the same goal in mind, is to give you ease when turning corners, like an open differential, but then engage and not totally lock up, but almost totally lock up when you lose traction, and then disengage again. The only ones that don't disengage are the spools, the mini-spools, or if you've welded your differential side gears to your differential pinion gears. And that, as I said, I think you'll regret that eventually. All right, well, that took a long time. We could spend a lot more time on differentials, but we've talked about 11 different ones and advantages and disadvantages to each of these. Thank you for watching.